Hello, and welcome. In this video, I'd like to explore the history of sound pressure level, or SPL. But when was sound pressure level actually born? Surprisingly, there is no simple answer. I would like to trace four important milestones. 1933, the mathematics. 1936, the definition. 1942, the concept. And 1951, the modern name and framework. Among these dates, 1942 will turn out to be especially important. This is where pressure level became clearly distinguished from sound intensity and intensity level, as a quantity in its own right. Our story begins in 1933, with Harvey Fletcher and Will Den Munson at Bell Telephone Laboratories. Their famous paper, Loudness, Its Definition, Measurement and Calculation, is well known today for the Fletcher-Munson equal loudness contours. But if we look carefully at the original graph, there is something important for the history of sound pressure level. The vertical axis does not say sound pressure level. It says intensity level, dB. Their acoustical framework was still based on sound intensity and intensity level. However, they were already using sound pressure to calculate intensity. For a plane or spherical progressive wave, sound intensity can be related to RMS sound pressure by I equals P RMS squared, divided by rho times C. This means that, under progressive wave conditions, an intensity ratio can be expressed as a squared pressure ratio. And when we put this relationship into the decibel equation, something very familiar appears. 10 times the base 10 logarithm of I divided by I naught becomes 20 times the base 10 logarithm of P RMS divided by P naught. This is essentially the mathematical form of modern sound pressure level. Fletcher and Munson used a reference intensity of 10 to the minus 12 watts per square meter. For a progressive wave in air, this corresponds to approximately 20.4 micropascals RMS, already very close to the modern reference pressure of 20 micropascals. So by 1933, the mathematical foundation of modern SPL was already there. But conceptually, the quantity was still being described as intensity level. 3 years later, something very significant happened. In October 1936, the Journal of the Acoustical Society of America published the American Tentative Standards for Noise Measurement, Z24.2, 1936. In this document, alongside sound intensity and intensity level, there is a separate item called pressure level. And its definition is remarkably familiar. Pressure level is defined as LP equals 20 times the base 10 logarithm of P divided by P naught. Even more importantly, the reference pressure is given as 0.0002 dyne per square centimeter. In modern SI units, that is exactly 20 micropascals. So in 1936, both the basic equation and the reference pressure of modern SPL were already present. But notice the title of the document. It was still a tentative standard. The direction was clear, but the terminology and the overall acoustical framework had not yet fully matured. This is why I describe 1936 as the milestone of definition, rather than the final establishment of sound pressure level. The years that followed are particularly interesting, because they show how slowly scientific terminology can change. In 1937, at the first International Acoustical Conference in Paris, the Measurement Committee discussed both intensity and pressure. The documents referred to a scale of intensity or pressure graduated in decibels, and even used the expression intensity level, or pressure level. So pressure level was clearly becoming part of the vocabulary. In the same year, the U.S. National Advisory Committee for Aeronautics, NACA, published Technical Note 629. Its title was A Sound Pressure Level Meter Without Amplification. So the expression, sound pressure level, was already being used in practical instrumentation. Yet even within that same document, one graph was still labeled simply pressure level, dB. Then, in 1938, Harvey Fletcher wrote, beta equals 10 times the logarithm of I, which equals 20 times the logarithm of P. Mathematically, this is again the same pressure logarithm structure we recognize today. But Fletcher still called the quantity intensity level. These examples show something important. Standards organizations, instrument engineers, and researchers were not all using the same terminology yet. The late 1930s were a genuine transitional period. This brings us to 1942. By 1942, the equation already existed. Pressure level had already been defined. So what was still missing? Conceptual independence. In the American Standard Acoustical Terminology, Z24.1, 1942, pressure level was explicitly defined separately from sound intensity and intensity level. Why is this distinction so important? Because sound pressure and sound intensity are fundamentally different physical quantities. Sound pressure describes the local pressure fluctuation at a point. Sound intensity describes the flow of acoustic energy. More generally, intensity depends on both sound pressure and particle velocity. It can be expressed as the time average of their product. I equals 1 divided by t, times the integral from 0 to t, of p of t times u of t, dt. Under a simple plane progressive wave condition, this becomes I equals p RMS squared, divided by rho naught times c. In that special case, sound pressure and sound intensity have a simple relationship. And pressure level and intensity level can correspond numerically. But here is the important point. This relationship only holds under certain conditions. In standing wave fields, near fields, and other complex sound fields, pressure alone does not uniquely determine the actual energy flow. A microphone can measure a large local pressure fluctuation, even when that pressure does not directly tell us how much acoustic energy is flowing through a surface. Pressure is not simply another name for intensity. This is the fundamental distinction. The 1942 standard made this distinction explicit. Pressure level was no longer merely a convenient way of expressing intensity level through pressure. It stood as an acoustical level quantity in its own right. That is why I regard 1942 as the most important conceptual turning point in the history of SPL. The next major milestone came in 1951. The new edition of the American Standard Acoustical Terminology, Z24.1, 1951, now explicitly used the term sound pressure level. Just before this definition, the standard also defined effective sound pressure, root mean square sound pressure. This made clear what pressure quantity was to be used in the SPL calculation. Sound pressure level was defined in essentially the form we use today. LP equals 20 times the base 10 logarithm of P divided by P naught. And importantly, the reference pressure was to be explicitly stated. A commonly used value for measurements in air was 20 micropascals. The same standard also organized the surrounding acoustical terminology, including the bell, the decibel, effective sound pressure, sound intensity, and intensity level. So 1951 was not the year when the underlying physics suddenly appeared. That had happened much earlier. Instead, 1951 gave sound pressure level its stable modern name, and placed it within a systematic acoustical framework. In other words, 1942 was the conceptual milestone. 1951 was the milestone of terminology and systematization. We can now summarize the development of sound pressure level in 4 milestones. 1933, mathematics. Under progressive wave conditions, pressure measurements could already be converted into the 20-log form that resembles modern SPL. 1936, definition. Pressure level was explicitly defined using 20 log, with a reference pressure of 20 micropascals. 1942, concept. Pressure level was explicitly separated from sound intensity and intensity level as an acoustical quantity in its own right. 1951, name and system. The term sound pressure level took its modern place within a systematic acoustical framework. So the development was not one single invention. The equation came first. Conceptual independence followed. And the stable modern name came later. Sound pressure level was not invented on a single day. It evolved. And that is why SPL has no single birthday. So SPL was not born in a single moment. It emerged step by step, through mathematics, definition, conceptual independence, and finally, a modern name. And that is how sound pressure level gradually took the form we know today. Thank you for watching. I hope you enjoyed this journey through the history of sound pressure level. See you in the next video.